Hello students, I am Dr. Sumit Majumdar. I am a pass out of IIT-JEE. I am from the 2003 batch. I am with askIITians since 2007. Today, we will be discussing about waves. You will have often seen, supposing you drop a pebble or a stone in basically some option of still water. In that case, what is the thing that happens? You see ripples flowing out, yeah? So those are the basic things, or those are the things which produce waves. They are known as waves. Waves are found everywhere throughout our journey through life. So we'll be starting off with waves. We'll be starting off with a kind of introduction to waves. Then we'll move over and try to understand about the different forms of energy that is associated with waves. We'll also try to understand the different types of waves, that there are something like standing waves, there are something like displacement waves, and so on and so forth. Then at the end, we'll be ending up with Doppler's effect. That is, if there is a displacement, a relative displacement between the source and the sound, in that case, how the frequency of the sound gets modified. So stay tuned for that. So students, the first topic that we'll be starting off is the introduction to waves. What exactly do waves stand for? What exactly we are going to study in waves? So let's start off with a quote. If you can't stop the waves, that you can learn how to surf. So that's a very, very important thing. This is realistic in your everyday life as well as in your studies, everything. So you cannot go against the waves, but if you keep on trying to conquer the waves, then you would be able to learn how to surf against those waves and move forward. Okay, so let's get going. What we all will be covering in this particular chapter? Broadly speaking, we'll be starting off with the wave motion. The wave motion can be characterized by two things. That is, we can differentiate into two basic parts. That is the transverse waves and the longitudinal waves. Going further, we'll be understanding about the wave properties. Then we'll try to understand about the equation of the traveling waves, because if there is a wave that moves from one point to another, that is what is known as a traveling wave. Further, we'll try to understand about the equation of simple harmonic progressive waves. Going further, what we'll try to get is a simple harmonic progressive wave is very, very important. Then the energy of plane progressive waves, that when any wave is traveling, obviously it's going to be carrying both material as well as energy. So the energy of a plane progressive wave, followed by the intensity of wave. If the wave is loud, or if the sound that you hear is loud or shrill, how exactly you are going to differentiate? So that is what is known as the intensity. That will be followed by trying to understand what are the different types of transverse waves that are produced in a stress string. So if there is a stress string, what all are going to be the transverse waves? Now the most important thing is this. Obviously there will be multiple types of waves that will be existing. How will you be able to find out the net resultant? So let's try to understand about the principle of superposition of waves. First of all, we'll be classifying that into concerns what exactly is interference. Supposing you have two waves starting from multiple places, or two or more waves starting from multiple places, and they're trying to add up. So obviously the properties of one are going to interfere with the properties of the other. That is what is meant by interference. Then we talk about the standing waves. As I mentioned it some time back, standing waves basically means that if there is no material or energy being transferred from one point to the other, so effectively the net result is that the wave is actually standing, it's not really moving, even though there can be one wave moving from one point to the other and the other opposite wave moving backwards. So the net resultant in that case is going to be zero. So that is what is meant by standing waves. In a similar way, supposing you have two boundaries, if one wave starts from one point, goes to the other, gets reflected back from the other point and comes back. So that is what is meant by the reflection of the waves. Stationary waves and strings. We'll try to understand what are the different types of stationary waves that are produced in a string. Sonometer. Sonometer is nothing but a device which helps us in understanding about the frequency of the wave that is produced in a string.
displacement wave and pressure wave. These are something which I would like to introduce when we move on to that. Sound waves in solids. You know that sound cannot move in an empty space. Sound needs a material medium. So, what are the different types of sound waves that are produced in solids? Then, as I mentioned before as well, the intensity. How much is the intensity of the waves that are produced? Moving further, we talk about the resonance. Resonance basically means when you have a frequency that is induced, and if an external frequency is being induced in a substance, in a system, which also has its own frequency, that results into resonance. So we'll try to understand for the case of longitudinal waves that are set up in an open pipe, and similarly for the case of closed pipe. You can draw an analogy with the case of a flute. So that's the same thing here. Resonance tube, we'll try to understand about that. In a similar way, when you have two frequencies very close together, very closely separated, in that case, there results into the formation of beats. That when the two frequencies are sounded together, that results into an increased frequency, which is what is known as the beats. Doppler's effect. So what is Doppler's effect? Let me give you a very brief introduction. Supposing you are standing at a particular place and you hear a sound of a train, let's say, approaching you. Yeah. So in that case, as the train comes close towards you, the frequency of the sound or the loudness of the sound keeps on increasing. And similarly, as the train goes past you, the frequency again comes down. So that is what we try to understand as to how the frequency is affected by the velocity of the observer and the source with respect to the velocity of the sound. So let's get going now. What is a wave? That is the foremost thing. So let's try to understand about that. So when we talk about waves, waves basically involve the transfer of disturbance. So if there is a wave that is moving from one point to the other, so there is going to be a transfer of energy or transfer of matter from one point to the other. So here if you look at it, so in this particular case, what you will have, let me just tell you that here the wave is moving like this. So obviously the wave is starting from this point, it's going to this point, then it's coming back here and so on. So this basically tells us about the maximum displacement, which is also known as the amplitude. And if you take any point here and similarly you go to another point here which is equal, means both the motions are equal, in that case the time it takes to go from between these positions, it is what is known as the time period of motion. This is how we define the waves. Now how exactly we are going to classify? Broadly speaking, we will be classifying the waves into two parts. That is, we are talking about mechanical waves. Mechanical waves means which need a material medium. So these mediums, or broadly speaking, if we are not talking about the electromagnetic waves to be precise, we can precisely differentiate between transverse waves and the longitudinal waves. Now we have to consider for the case of sound is a different type of a wave and light is a different type of a wave. So let's try to understand what is the difference. If we are talking about for the case of a longitudinal wave, as you can see, if we take the case of a spring, let's say, so if you try to compress or you expand, the motion of the spring is along the same direction as its motion of the amplitude. So here it's either getting compressed like this or it's getting expanded like here. So this is the basic difference between compression and rarefaction. So here the motion of the particle is in the same direction as its oscillation. Whereas if you talk about this particular case of transverse waves, so here if you just draw a line like this, then you can see that the oscillations are taking place perpendicular to the direction of motion. The motion is taking place towards the north, whereas the oscillations are taking place perpendicular to that. So this is the way the wave is going to travel. So this is the basic difference between a longitudinal wave and a transverse wave. So light follows the case of transverse wave, whereas sound follows the case of a longitudinal wave. If you move on and try to understand about what exactly is a transverse wave. So for the case of a transverse wave, this is a kind of 3D picture that I have tried to tell you. So we try to define a couple of things. the points of least amplitude, that is of negative amplitude, is defined as trough. The point of positive amplitude or the maximum positive amplitude is what is known as the crest. So if we have something like this, then this point is going to be known as a crest and this point is going to be known as a trough. And generally the wave is going to be moving towards right or towards left, that is perpendicular to its oscillation. So this is the direction of motion, and between starting from one crest to one trough or vice versa, the distance that it covers is what is known as the wavelength. So what we have here, so transverse wave is characterized by a particle motion that is perpendicular to the wave energy. The wave energy is going to be moving towards a particular direction and the oscillations are going to be taking place perpendicular to it. So it's important to understand that the individual particles do not move from their original position on the horizontal axis. They are not moving, they are just transferring the energy. Right? So for instance, let's say you drop a stone, yeah? So if you drop a stone in a still water, in a place of still water, what you are going to observe? Think about it. You are going to observe that there are ripples which are going to flow out, yeah? So when the ripples flow out outside from the point where the stone falls down, that creates, the stone is not moving at all. It's just that because the stone has transferred its energy, that energy is transferred or that energy is percolated in the forward direction. So that is what is known as the motion of a wave. So this kind of a motion or this kind of a transfer of energy is the thing that takes place. Now moving on, if we talk about for the case of a longitudinal wave. A longitudinal wave is characterized by particle motion that is parallel to the direction of the wave energy. So here the particles are moving along the same direction as well as they are oscillating. So there is a transfer of energy taking place along the same direction as its oscillation. So this is what is meant by a longitudinal energy. Longitudinal wave to be precise. So here, even though they are moving along the same direction, it is important to note that the particle does not move with the wave. The particle is still at the same point. It's just oscillating, please understand. And while oscillating, it is transferring the energy from one point to the other, right? So that is what is meant by a longitudinal wave. Now if we move on and try to talk about going further about the circular waves. Circular waves are the case that I just mentioned some time back about the ripples being formed. So here as you see, if you drop a stone and the stone helps in the ripples being formed, so that is what is known as a circular wave. So a circular wave, to be precise, to be defining it, we can say that a wave that has circular wave fronts that move outwards. So wave fronts basically mean that the displacement from its origin or from the center is constant. So that is what is meant by a circular wave. Further, if we have to talk about the plane wave and its wave front. Plane waves are such that you cannot really say that they are originating from some point. You have to say that they are just plane perpendicular waves. Obviously, if they cannot originate at a particular point, that means they are not circular in nature. That means they would have originated at infinity. That's the reason you have plane parallel waves. So that is what is meant by a plane wave front. Further, going ahead, if you have to understand about what is the speed of a longitudinal wave. So the speed of a longitudinal wave is defined as the square root, the radical of bulk modulus over elasticity. Now, if we are talking about a gas, then there is also a Newtonian correction as gamma. So gamma talks about the elasticity of that particular gas. Gamma times the pressure divided by the density. If we are talking about a solid, for the case of a solid, it's just going to be the elasticity divided by the density. And for the case of a liquid, if you have it, so it's basically the bulk modulus, because in the case of a liquid, the pressure is going to be surrounded everywhere, and so it's going to be just the bulk modulus over the density. So here B stands for the bulk modulus, rho stands for the density of the gas, and gamma is the adiabatic bulk modulus, Y is the Young's modulus, P is the pressure. Okay, I would like to say that this is nothing but the Young's modulus Y. Okay, let's move on. And let's try to understand about the properties. When the wave is actually moving from a point, there are going to be the speed that is going to be associated. Also, when the wave is moving, so after a certain interval of time, it's going to be repeating itself. So since it's going to be repeating itself, so there is going to be something known as the wave frequency. So there is going to be a frequency of oscillation, and inverse of the frequency gives us the time period. We have already talked about the amplitude. Amplitude is the maximum displacement from its original point. Wavelength is the distance between consecutive crests or consecutive troughs. Phase. Phase is very, very important. Let's try to understand about what is a phase. Now, supposing here, as I mentioned, let's say that this particular point is O. The wave is just starting from here, and the distance between this is what gives you 1 lambda. Similarly, the distance between these two gives you lambda, and this particular thing is nothing but the amplitude A. Right? So moving along the horizontal direction. Fine. Now, since it's moving along the horizontal direction, now let me just take the case of another wave. Let's say another wave starts somewhere from here and it goes like this. So if it goes like this, as you can see, it has started later on, right? Since it has started later on, so obviously there has to be some difference. You have to show some difference. So the difference between these two are covered in terms of the phase difference phi. So all the properties remaining the same, the time period remains the same, the amplitude remains the same, the wavelength remains the same, the frequency remains the same. It's just that the second wave is starting later on. So that's the reason this is what is meant by the frequency, the phase difference of the wave, right? So hopefully you have understood till this point. Stay tuned for the next part.
So as we discussed about the different types of waves, the different type of energy that is associated with the waves, and so on and so forth. So now moving on, we'll try to identify what is the energy that is associated with the waves. Because when the waves move from one point to the other, obviously there is some amount of energy that is transferred. Not necessarily there is a particle transferred, but it's the energy that is transferred. So stay tuned for the next part.